Now that we've learned about functions, we're going to learn about how we can do algebra with functions. So the very basic thing we can do is take two functions and add, subtract, multiply, or divide them to get a new function. So we can have, if we have functions f of x and g of x. So we'll see an example here. It's better turn my pen on. So we're going to let f of x be x plus 2 and g of x be the square root of x plus 5. Okay, so you have two different functions. You can make a new function f plus g of x by taking the first function. So we would take the x plus 2, the expression, plus the expression for g of x. Okay, subtracting f minus g of x, you're going to subtract the two functions. F times g of x, which we can just put them next to each other, f g of x. You multiply them, and then dividing. And we'll talk about the domains a little bit later, but one thing we have to be careful about when we divide is anything that made g of x 0 can no longer be in the domain of f divided by g of x, because then you would be dividing by 0, and we know that's not allowed. Okay, so let's work through this first example. So it says, given f of x is equal to x plus 2 and g of x is equal to the square root of x plus 5, find f plus g of x. So we're just going to take f of x, the expression x plus 2, and add to it the square root of x plus 5. And if there was any simplification we could do, we would do it, but here there's nothing we can do to simplify. That is our final answer. Okay, the next one asks for f plus g of 3. Well, we found f plus g of x, so now we're just going to plug in 3 to what we found above. So we would have 3 plus 2 plus the square root of 3 plus 5. So here we can combine it and say, combine the 3 plus 2, that gives us 5 plus the square root of 8. And we can take it one step further. 8, if we think about 8, it's 4 times 2. So we can, because of the 4, we can pull a 2 out front. So we'd have 5 plus 2 square root of 2. Okay, and then if we want f plus g of negative 6, we would plug negative 6 in. Oops, that should be a plus. So here we would have negative 4 plus the square root of negative 1. And in the real numbers, before we get into complex numbers or anything like that, in the real numbers, this is undefined. So here, because we have a square root of a negative number, we would say undefined. And we actually could have known that this was undefined before if we look at the domains of f of x and g of x. So f of x is a polynomial x plus 2. The domain of f of x would be all real numbers, or negative infinity to infinity. But look at g of x. G of x is a root function, a radical function. And to find the domain of radical functions, we've talked about how you take the radicand, the thing under the square root, set it greater than or equal to 0, and solve for x. So we'd get the x has to be greater than or equal to negative 5. So the domain of g of x is from negative 5 to infinity, and negative 6 is less than negative 5. It's not in there. And the rule about domains, we'll talk about it more later, is that for something to be in the domain of f plus g of x, f minus g of x, f times g of x, and f divided by g of x, it has to be in the domain of both f of x and g of x. So if it's not in the domain of one of them, you know it's going to be undefined. It won't be in the domain. Okay, but in general, if something is in the domain of both of them, to find f plus g of something, you would just plug it into f plus g of x.